Okay, cool. Yeah, so how did recursion yesterday go with Alec?
I have a tough time. Like I think about it in loops, but like I'm kind of like combining loops and recursion into one non-working function. So what's that understand?
Hmm. Anyone else? Okay, cool. Yeah, I guess actually, so what you said there is actually pretty important. I actually think it in a lot of ways makes it more confusing. This idea that so far, all the problems that we've done yesterday with recursion, we're actually able to do with for loops, or at least with other things besides recursion. And so I think, given that recursion is a new thing and it can be a bit tricky to grasp, there's always this tendency to kind of revert back to the things that we know and feel like are easier, right? So in this case, it would be more traditional loops. And so today we're going to talk about the second part of recursion, which is actually very similar to what we did yesterday. In fact, the concepts are almost identical. The only difference now is that the problems that we choose to do today are different than yesterday's, in the sense that the problems that we do today are actually not solvable via traditional for loops, or at least not very solvable via kind of the things that we've already been covering. And so today's problems will definitely need recursion. And so, for better or worse, we're going to kind of push you outside of the comfort zone of traditional for loops. And we're going to make you do things that essentially, has to leverage recursion. So let's do the lecture, and then I'll have you guys get started on the workshop, and then we'll talk at the very end about kind of how this applies, kind of potentially during the interview, or even during future problems, for interviews that you might see. Okay, cool. So yesterday, we walked through the very basics of recursion, which is to say that the very core idea behind recursion is, rather than trying to do one massive problem X number of times, why don't we just do one simple problems, or sorry, why don't we just try to solve one simple problem as many times as we need to until we get to the solution, right? And so if I look at here, as an example, I have a very simple function that all it does is logs an array, okay? And before you get nervous about reading it, there's no recursion here, right? It's just a function that takes in an array. We go through the length of the array, and then for every single element in the array, we print out the element, right? Very, very standard loop, traditional for loops. Now, the issue with this loop as we have it, or rather the issue with this function as we currently have it constructed is this handles this, or rather this function works very well if there's no nesting. If every single element that we have is a number or what have you, this works perfectly well. But if there is a level of nesting, so in this case, if the second element of the array is another array with two other elements, well, now we actually run into a problem, because if we actually run the input with the nested array into the original function, we get a printout of two lines. The first line is a number, which is we're totally fine with, right? But the second printout is not a number, it's actually an array of multiple numbers. And so the question we want to solve here is, how do we actually write a function that is able to go into the nesting and print out each number individually on its own line? Okay, and so the way for us to do, or rather, let me just kind of go back here and take a look at this, right? One thing I just want you to be aware of here is that, if I tell you for a fact that there's going to be two levels of nesting in this array, you might say, well, why don't I just write another for loop inside of it? And that sounds like it could be a very viable solution to help us get around the fact that there's two levels of nesting. But what if I don't tell you how many levels of nesting there are, right? Or rather, what if there could be infinite levels of nesting, right? What if inside the nested array we have another nested array, we have another nested array, and so on and so forth, and it goes all the way, indefinitely, right? We don't actually know how many levels there are. Well, then if we only have the for loop as our the for loop tool at our disposal, then we actually run into a problem where we actually don't know how many times, or rather how many iterations deep we need to go with the for loop. And so in that case, the for loop becomes a really bad or suboptimal solution for our problem. And so the way to solve this type of problem, where unlike yesterday, we don't know how many times we need to do something, this is where recursion really shines and can be the most powerful. Okay, So the way we get around this yesterday, hopefully a lot of this should look familiar with regarding yesterday, is the first part of the function still looks the same. We still write a logs and array function. We still iterate through every single element in the array, and we take out each element. But now we actually split the rest of the function in an if-else statement, and we do two things, right? If the element, and I'll jump to the else first. If the element is not an array, well, if it's just a number, and I'm assuming that everything is either an array or a number. If it's not an array and it's just a number, well, let's just go to line 9, do what we were doing previously, which is just console logging out the element, right? And we're done, and we go on to the next element. But if the element is an array, so if array.is an array on line 5 there, if that returns true, well, now the problem we have to solve is actually saying, hey, I have an array of numbers. How do I print out every single number in that array? And we kind of realize that, hey, that's the same problem we've been solving all along, except now we're going to solve it kind of one level deeper, right? And so if I take a look at an example here, right, if I was to go through logs in array and I actually run this function out, the first time I do it, if I look at my call stack, all I'm doing is checking the first element, which is a 1. So my if clause is not triggered, and so I go to my else clause and I just console log out 1, right? After I console log out 1, I go to the next element, which is the array 2, 3. And now I have to solve this inner problem, right? Because as I go through this for loop, on line 3, I establish that element is the array 2, 3. I go line 5 and I say, is this element an array? And the answer is yes, it is. And so because of that, we go to line 6, where we need to solve this problem of logs an array, and our element now becomes the array 2, 3. Okay, so now we're actually recursively calling logs an array, and so the way that we then move on is to say, well, let's solve logs an array with the array 2, 3 first, right? As I call this function again, and I go through this whole thing again, array is now just an array with two numbers, 2, 3. As I go through my for loop, the first element is in number 2, so it's not an array, so I'm very comfortable just console logging it out. And then the second number is just a number 3. And once again, it's not an array, so I'm very comfortable just console logging it out, right? I go to 2, I go to 3, and now I've reached the end of my logs and array function, right? Because I'm supposed to iterate through the array 2, 3, and I did. There's nothing else I have to do, so I can take that off my call stack, right, or my to-do list, if you will, and go back to where I left off. Well, where I left off was I was processing this array with two things. The first element being number 1, the second element being the array 2, 3. And once I've solved that problem, well, then it becomes really easy for me because I can say, great, I've now reached the end of my array, and now I'm done with that function call. And now what I've been able to do is I'm actually able to go through, and regardless of the level of nesting in the array, I'm able to print out each number individually on its own line. Okay. And once again, just to kind of really make it clear, the secret sauce of the recursion here, right, is this idea on lines 5 through 10, where we say if the element is an array, then we're going to recursively call and have you solve a smaller problem, right? We're not saying you've solved everything, but we're saying we're going to have you solve a smaller problem, right? So before the array was 1, comma, the array 2, 3, then we're going to say, great, now just solve the array 2, 3. Right? All we've done is peel back the nesting by one layer. And in fact, each time we call this array, we're going to peel back the nesting, if there are any, by one layer. And so we're not, in no single step are we saying, we're definitely going to solve this entire problem right here in this one step. But each problem just says, hey, I'm going to peel off one layer of nesting, and you take a look at what's inside. If you can finish it off, if it's all numbers, then we're good. If it's not, if it's more nested arrays, then you're going to peel off one extra layer and hand off to the next iteration or the next recursive call of this function. Right? And so fundamentally, that's just the idea that we're going after here, right? It's just that now, regardless of how many layers of nesting there's going to be in this nested array, because each recursive call will just peel away one layer of nesting, we know that the recursion will eventually reach a point in which there are no more levels of nesting, and we're done. And our function is actually able to handle any number of levels of nesting in the array. So this could be a bit intimidating here, but are there any questions? This makes sense? Actually, everyone understands this?
I mean, enough, I guess.
Cool. All right, we're gonna go through two more examples, so just bear with me here. And once again, obviously, feel free to jump in at any point with questions. Um, so let's take a look at another example, right? And these examples are all hopefully pretty similar at this point. Conceptually, we're actually doing pretty much the same thing over and over again, except now we're actually going to move into, rather than just console logging things out, we're going to move into something that could be a little bit more confusing, which is saying, hey, rather than console logging things out, let's start returning things, okay? And so concat else. What does this function do? All concat else does is it takes in an array of, of letters, and it just joins together all of the letters into a single string, okay? Now, I'm aware that the join function does this for us, but for now, let's just try building this ourselves, okay? So if there's no layers of nesting, then in order to join all of the letters in an array, I'm at function, it takes in an array of letters, I initialize an empty string, and then I just go through every single element in the array, and for each element, I add it to my final string, which I do on line 5 there, add my final string, da-da-da, all the way to the very end. After I've added every single letter to the final string, on line 7 there, I return the final string, and my function is complete, okay? With no levels of nesting, it is this easy to join together a bunch of elements, or rather a bunch of string elements into a single string. Now, obviously, as you can probably imagine, the difficulty comes when we talk about, okay, well, what if here on line 13 there, if I look at the input there, right? What if rather than having just an array of strings, I could have an array of strings, or other arrays of strings, right? So once again, we go back to our nested array problem here. And so if I look at the function now as I've written it, the first part actually looks very similar, right? I still initialize an empty final string variable. I'm still going through every single element in the array on line 3 there. And then lastly on line 11, notice how I'm still returning final string. So far, these three aspects are identical to what we saw before. The difference now here is we need to be more careful. How do we handle nested arrays, or rather, how do we handle array elements differently than how we handle string elements? Okay, so if the element is a string, and even though we don't see it in the if statement, that by definition means we are going to find it in the else statement, right? On line 8, I'm sorry, on line 7 there, right? If the element is a string, then on line 8, all we do is what we did previously, which is we add the element to our final string so far, right? We add a letter to a pre-existing string. However, if the element is an array, so on line 5, if that triggers, right? If now for example, we're adding the inner element of b comma c, well then what we do is we still call concat else, but what is concat else, right? If I call concat else, what is it going to give me? It's going to give me back a string of all of the letters in the array. And so giving me back a string of letters by itself is fine, but I then need to add that to my final string, right? So let's take a look at how this code looks in practice. Initially, when I call concat else, I'm passing in an array with the first element, which is the letter A, and then I'm my array of b comma c, okay? So when I add in the first element, my final string becomes just A, okay? Now, the important part is when I go to my second element and my array.isArray clause on line 5 is triggered, it becomes true. Then when I move on to line 6, I need to say final string, which is the letter A, plus or equal, right? Which means I need to add the final string I already have to what I get when I join in all the letters in my new array of b comma c, right? And this is super important. I think a lot of folks mess this up here, is that they don't add the right-hand side of concat else, passing an element, to final string. And if we don't do that, then all we're saying is, hey, great, here's this brand new string, and you do nothing with it, right? The reason why, and this is kind of a good rule of thumb usually, whenever you call a function, you ask for something back, you should almost always be doing something with that return value, okay? And so once again, if I'm on the array b comma c and I just move on to line 6 here, this tells me I now need to solve concat else of the array b comma c before I move further in my code. So if I do call concat else and I pass in the array b comma c, I initialize my final string, I go through the array. Now the elements are just single characters b comma c, And so I add B to final string and I get back B. I add C to final string, I get back BC. And then on line 11, I return final string, and now I'm done calling concat else the array B comma C, and now I can return the string BC to where it was called, and voila, I have now final string is plus or equal to the string BC, and once again this means final string is equal to the current value of final string, which is A, plus the value of the string BC, right? So now this gives back the string ABC or ABC. I'm now also done processing the original array because I've gone through both elements, and so my for loop is over, and I can move on to line 11 where I'm returning the final string, which is in this case would just be the string ABC. Any questions here? Cool. All right then. So the last thing we'll talk about is this idea of nested objects. And really, in my opinion, there's not too much to talk about because nested objects actually works identically to nested arrays, right? In the sense that you can have multiple layers of nesting. All you have to do in your code is figure out, great, now how do I set up something that can traverse that thing, right? With a nested array, we use a for loop, and we know that with objects, typically speak, if I want to iterate through all the key value pairs in an object, then I use our handy for loop, right? And so here, if I'm trying to create a function called sumVals, and which all it does is takes in a nested objects and adds up all of the values in the objects. Well, if I take a look at on line 12 there, if I'm trying to add an object which has two keys, A and B, and the values are 10 and 20, well, when I call sumVals and I pass in the object, sum equals 0, and I say for let key in obj, let value equal the first value, I add that to the sum, I move on to the next value, I add that to the sum, so I add 10 to sum, so now sum is 10, I now add 20 to sum, so sum is now 30, and then on line 9 I return 30, and so once again, no recursion here, just very straightforward object value addition. But what if I come across a situation now where on line 14 there I have this really nasty multi-layer nested array, or sorry, multi-layer nested object? How do I handle that? Well, once again, the function actually looks pretty similar for the most part. I still take in an object. On line 2, I still addition my sum equals 0. On line 3, I'm still using my for loop. On line 4, I still take a look at the value of each key value pair. And then on line 10, on 11, after I'm done adding all numbers, I still return the sum, right? So far, everything is consistent with what we saw in the previous slide. The only difference now here is I now have another if-else clause, right? I say if the if the value is an object, let's do something else. But if it's not an object, which in this case would mean say that if you're not an object, you're a number. If you're a number, then we go to line 8, and we just add the value to the sum, right? Pretty straightforward there. But if you are an object, well then we still need to add something to the sum, but now we need to add in the sum of the value of the nested object, okay? So if I was to kind of follow the logic of this code through now, sumVals of all of this, right? And so when I check the first value of A, it's just 1, so I just add 1 to the initial sum of 0, so I get back 1. And then when I go to the second key value pair, I add the value. Well, the value is an object, and so therefore I move on to line 6, and I need to add in that object into my number. Cool. So when I do that, I see that sumVals. So I now need to figure out the sumVals of this inner nested object. Well, when I do that, there's only one key value pair, but the value is an object. So that takes me to line 6 on the recursive call. It says, great, now you need to figure out what the sumVals of that inner nested object is. And notice how each level that I go into, I'm just peeling away one layer of nesting. And I keep doing this, and finally I reach here, in which the object I have has two key value pairs, and the values for both objects are just plain numbers. So now I will add 2 to 0, and then add 3 to 2 to 5, and now I can actually start working back my chain, right? If I know the sumVals of this object is 5, let's add it to where it was called. So I'm adding 5 to 0, and so I get back 5. And then I add back 5 to that 0, and now I get back 5. and then that returns a 5, which I then add back to my existing sum that I was processing before, right? And remember, I've already had 1 there because that was the first value that I processed, and so I need to add 5 to that 1, and I have 6, and so therefore when I return this value, I get back 6. Okay, so the logic is almost identical to what we saw for the nested arrays. The only difference now is that we're using a for loop to work through the object rather than using a traditional for loop to work through the array. Any questions here? Cool. Awesome. So, I mean, that was pretty much it, right? That was all I had. So, a lot of this hopefully is repetitive from yesterday. And I say repetitive in the sense that we're still using the same type of recursion principles. The only difference now from yesterday